Multiplying and dividing fractions is a lot easier to do than the adding and subtracting part because we don't have the requirement of needing to have common denominators. All we have to do when we multiply or divide is to just multiply the numerators together. And without actually distributing anything, I'll have 5r times r plus 5 times r minus 9. And same thing in the denominator. We multiply the numerator straight across and we multiply the denominator straight across. So we'll have r minus 2 times r minus 9 and r plus 5. Okay. Once numerator and denominator are all factored out, we just have to cancel common factors. So I see that I have this r minus 5 in the numerator and in the denominator. Those two will cancel. And so will the r minus 9s that are both in the numerator and the denominator. Everything that's left are factors that are not the same in the numerator and denominator. So we're done. 5r over r minus 2. When it comes to dividing, we have to remember the one rule there is for dividing. Dividing by a fraction is the same as multiplying by the reciprocal. Now that means that we leave the first fraction the same as that 5n over 7. Right? And it's dividing by the fraction that changes into multiplying by the reciprocal. So dividing changes into multiplying. And it's the fraction 8n over 5n that turns into its reciprocal, 5n over 8n. Now that it's just multiplying, all we have to do is multiply straight across the numerator, 25n squared, and straight across the denominator, 56n. And we can see that, of course, this n will cancel with one of these n's, and our solution, our simplified answer, is 25n over 56. You might run into two fractions like 5n minus 20 over n minus 1 and 6n plus 6 over n minus 4, in which nothing looks like it cancels right away. But at the same time, we still have to multiply them together. What you should do is, as you're multiplying the numerators together, break it into its factors. Looking at 5n minus 20, I can see that there's a common factor of 5. So I'm going to factor a 5 out of there, and I'll be left with n minus 4. In the second fraction, 6n plus 6, obviously 6 is a common factor, so I'll factor that out, and I'll be left with n plus 1. In the denominator, there's just n minus 1 and n minus 4. So we go ahead and look for any factors that can cancel. N minus 4 is the same in the numerator and the denominator, so they'll cancel. However, this n minus 1 and n plus 1 are not the same, so they do not cancel. They look like maybe they should because of the plus 1 minus 1 thing, but they're not exactly the same factors, so they can't cancel. That means we're done, and it's just simplify. 5 times 6 is 30, n plus 1 over n minus 1, and that's it. The last one in problem 4 is another division problem, so we're going to multiply that by the reciprocal. And when we turn it into a multiplication problem, what we should do is factor it along the way. So this x squared plus 7x plus 12, we know that that can factor into x plus 4 and x plus 3. The denominator of that fraction, x squared minus x minus 20, this can be factored into x minus 5 and x plus 4. And we're going to multiply by the reciprocal. So instead of division, this is where the multiplication comes in. And we'll take the reciprocal of this fraction. So the numerator is going to be the x plus 3, and the denominator will be the x minus 5. Now that it's written as multiplication, we go and look for common factors. And I see this x plus 4 that can cancel. And the x plus 3's, because they're both in the numerator, cannot cancel. And the same thing with the x minus 5's. Because they're both in the denominator, they don't cancel with each other. That means that our simplified fraction here is going to be x plus 3 squared over x minus 5 squared. And that's simplified.